Hey there, EV enthusiasts. Have you ever wondered what would happen if your electric car faced an invisible, unstoppable force? Enter the electromagnetic pulse, or EMP. It's the ultimate electronic disruptor. But how does it stack up against the high-tech systems in your EV? In today's video, we're diving into the battle of the century EV versus EMP. We'll explore how EMPs work, what they can do to your car, and whether current EVs are ready to take on this invisible threat. First, what is an EMP? It stands for electromagnetic pulse, a sudden burst of energy in the form of electric and magnetic fields. Think of it like an invisible shock wave traveling through the air and zapping anything electronic in its path. Did you know EMPs can occur naturally or be man-made? For example, lightning strikes or solar flares from the sun create EMPs that can interfere with power grids. But humans have taken it a step further. Man-made EMPs come from nuclear explosions or special weapons designed to disable electronics. Here's how it works. An EMP releases a massive amount of energy that creates intense electric and magnetic fields. These fields travel quickly and can induce surges of current in electronic circuits. And guess what? Most devices aren't built to handle this overload. The intensity and damage depend on three things. 1. Strength of the EMP. A small EMP might glitch your phone. A strong one could knock out an entire city's power grid. 2. Duration. A longer pulse means more damage. 3. Shielding. Devices with proper shielding can survive, but most everyday tech isn't equipped for it. Did you know your electric vehicle could face invisible threats from something called an EMP, electromagnetic pulse? Don't worry. We're not talking sci-fi, but real-world scenarios that can mess with your car. Let's dive into 5 sources of EMPs you need to know about. First up, lightning strikes. Every time a lightning bolt hits nearby, it generates an EMP-like surge. If your EV is charging during a storm, that surge can travel through the power grid and potentially damage your car's electronics. Pro tip: unplug your EV during thunderstorms. Your car will thank you. Next, we've got power line surges. These happen when there's a sudden spike in electricity, like during a grid malfunction or when power comes back after an outage. If your EV is connected to a charger, that surge could overload its systems. Solution? Invest in a surge protector for your home charger. It's a lifesaver. Now here's one you might not expect. Intentional electromagnetic interference, or IEM. I think of it as EMPs, used deliberately like a gadget designed to disable electronics. While it's rare, it's a potential risk in areas where malicious intent might be a concern. Don't panic, this one's more of a movie plot than a daily worry for most of us. Ever parked near a factory? Some industrial machines, like high-frequency welders or induction heaters, create strong electromagnetic waves that could interfere with your EV. It's not common, but it's good to know. Let's just say parking near giant machines isn't ideal for your car's health. Last but not least, electromagnetic compatibility, EMC, failures in charging stations. Poorly shielded or low-quality chargers can emit electromagnetic waves that mimic EMP effects. If your EV is charging, it could mess with its electronics. Stick to certified, well-designed chargers, and you'll avoid this issue entirely. Imagine this: a powerful electromagnetic pulse, or EMP, hits your electric vehicle. What happens next? First, let's talk about the initial interaction. When an EMP strikes, it generates an intense electromagnetic field around your EV. This field induces large currents in the car's wiring and circuits, creating electrical chaos inside. Now let's see how it affects the critical systems that keep your EV running. 1. We got the Battery Management System, or BMS. The BMS manages your EV's charging and health. An EMP surge can disrupt or destroy it, leaving your battery unable to function properly or even failing completely. 2. The electric motor controller. The motor controller regulates power to the wheels. Voltage spikes from an EMP can fry its transistors, making your car undrivable. 3. The onboard computers. From navigation to driver assistance features, your car's computers are highly sensitive to EMPs. They could experience data corruption, crashes, or even permanent failure. 4. The communication systems. Your EV's communication systems like GPS, cellular, and vehicle-to-infrastructure links could go offline, leaving you disconnected. 5. The sensors. Autonomous or semi-autonomous EVs rely on sensors like radar and LiDAR. An EMP could knock these out, impacting safety and driving capabilities. 6. The battery pack. And finally, the battery pack itself. EMP-induced currents can cause overheating, short circuits, or even fires. Here's the kicker. Even if your EV seems fine after an EMP, longer-term effects can show up later. Software and firmware might get corrupted. Standard diagnostics might miss the damage. And you guessed it, your warranty likely won't cover EMP-related issues. The outcome of an EMP hit depends on its intensity. Here's what you can expect. 1. Mild EMP. Small disruptions like glitches in infotainment or navigation systems, annoying but manageable. 2. Moderate EMP. Damage to critical systems like the BMS or motor controller, leaving your car inoperable until repaired. 3. Severe EMP. Permanent damage to most components. The car becomes a very expensive paperweight, and repairs might not even be an option. Ever wondered how your electric vehicle protects itself from electrical shocks or interference? From lightning strikes to minor power surges, EVs are packed with smart technology to handle the unexpected. But are they ready for an EMP? Let's dive into the precautionary measures in EVs and find out. First up, surge protection. EVs are equipped with onboard surge protectors to handle voltage spikes from power grid fluctuations or even nearby lightning strikes. These protect your EV's battery and electronics from small surges. But here's the catch. They're not designed to handle the intense energy of a high-powered EMP. Think of it like an umbrella. It works in light rain, but not a hurricane. Next, let's talk about electromagnetic compatibility, or EMC. EVs must meet strict standards to reduce interference from other electronic devices, like your phone or nearby Wi-Fi signals. So, no need to worry about your EV freaking out when your Bluetooth speaker's nearby. But EMC standards only handle normal interference, not the intense energy burst of an EMP. It's like wearing sunglasses to block the sun. You'll still get blinded by a flashbang. And finally, there's shielding. Some EVs include basic electromagnetic shielding for critical systems like the BMS and motor controllers to block localized interference. This provides some protection against low-intensity EMPs or minor electromagnetic interference, but against a strong EMP. It's like using a bicycle helmet in a rock slide. Better than nothing, but not nearly enough. So, where does that leave us? Current EV technology has some safeguards like surge protection, EMC standards, and basic shielding. But when it comes to high-intensity EMPs, these measures aren't designed to handle the extreme energy involved. We all know electric vehicles are the future, but there's one invisible challenge they face: EMP protection. Why is it so hard to shield EVs from an electromagnetic pulse? Let's break it down into 3 key challenges you need to know. Challenge number 1. EMP waves cover a massive frequency spectrum. Think of it like trying to block every sound from a dog's bark to a bass drum. It's nearly impossible to design a shield that handles it all. Some parts of the EMP might bounce off, but others will sneak right through. That's why protecting against all frequencies is so tricky. Next up, cost and weight. Comprehensive shielding, like a full Faraday cage around the car, sounds cool, but it would add significant weight to the EV. More weight means less efficiency, which means shorter range, and let's be honest, no one wants to sacrifice their EV's mileage. And let's not forget the cost. Adding high-end EMP protection would make EVs much more expensive, putting them out of reach for many buyers. Finally, EVs rely heavily on sensitive electronics like microprocessors, sensors, and advanced software. These components are highly vulnerable to the powerful currents induced by an EMP. Imagine trying to protect thousands of delicate systems from one massive electrical wave. It's like defending a sandcastle from a tidal wave. So, we've learned that while electric vehicles are packed with advanced technology, they're not invincible. EMPs pose a real challenge with their ability to disrupt and damage sensitive electronics. But don't worry, it's not all doom and gloom. From surge protection to electromagnetic shielding, engineers are already working on solutions to make EVs more resilient. The big question now is how much protection do we really need, and at what cost? What do you think? Should automakers prioritize EMP proofing, or is this a rare enough risk to skip? Let me know your thoughts in the comments below. And if you enjoyed this deep dive into the world of EVs and EMPs, don't forget to give this video a thumbs up, subscribe to the channel, and hit that bell so you never miss an update. Together, we'll keep exploring the future of tech.